So I did my presentation on Lab 2. It was the lab about quantifying electrical signals. The goals for this lab were to get a better understanding of the methods that you use to quantify and record electrical signals and the tools that you use to do them. The lab focused on both AC and DC type signals. These signals were generated from a function generator or a power supply. And the properties of these signals were used in post-processing to discuss further things you can do with these waves, how you can manipulate them, and what type of data you can expect to get from them. The lab setup follows these two pictures on the side. These apparatuses are also labeled in the procedures, so when they're used, it will discuss them. The equipment that we used were a function generator here, a power supply to generate the waves as mentioned before, a multimeter to measure the waves and the signals, and an oscilloscope to visually measure it as well as measure it with different properties of the waves. The first procedure for assignment 1 was to set up the oscilloscope. You need to turn it on, load the default settings, and then you would change the amplification factor, which is what amplifies the wave, so you can usually see it on smaller, lower amplitude waves, from 10 to 1. Set the vertical axis, which is the little grid that's there, to 5 volts per division, meaning that for if the signal is at 1 above the baseline, it is a 5 volt signal. And set the horizontal scale to 5 milliseconds, meaning it will allow us to see functions that might have higher frequencies. So assignment 2 was to actually start recording data. We would set it up with the function generator attached to a T connector, going to the multimeter and the oscilloscope. Turn the function generator on, turn AC coupling on the oscilloscope, and then record the voltage peak to peak, voltage peak, and voltage RMS and period of the settings. Here's the results that were gotten from this. The channel is listed because the channel was recording two separate things on the oscilloscope. The frequency is listed there, and the period as well. Assignment 3 was to Assignment 3, we set the multimeter to DC. Following the procedure apparatus, following the apparatus that was listed before the picture for assignment 3, turn on the second channel on the oscilloscope. Function generator, set it to 5 volt RMS at 100 hertz. Set the vertical scale on the oscilloscope to 5 volts per division. We were still there. Turn on the DC coupling on channel 2. Output voltage on the function generator, on the power supply, set it to 10 volts. And then record the voltage peak to peak, voltage peak, and voltage RMS. Turn on the AC coupling, and when we did this in the lab, the signal disappeared because it was an alternating signal, and the AC coupling got rid of that. Here's the results, similar to before, in table view of the voltage peak to peak, and VRMS. For assignment 4, this is when we started to do some different things, more complicated setups. Keep the setup identical to assignment 2, so keep the same apparatus that was listed before. Set the output function generator to 5 volt peak at 100 megahertz. Turn on AC coupling, and then we would begin to vary the output frequency from 100 hertz to 1 megahertz in about 15 steps. Then we were trying to plot the decibel, the gain, versus the frequency. Here is the table from that data. The graph is at the end of the presentation. We'll discuss that a little bit further on. Here's assignment 5. The same equipment as assignment 4. Turn on the filter this time, which is another piece of equipment, and set the output frequency to 100 hertz at 5 kilohertz, varying in small increments. I forgot to mention that the filter is turned on at a cutoff frequency of 2 kilohertz, and then record voltage in, voltage out on the oscilloscope and multimeter. Again, the plot is going to be right here. So assignment 4 and assignment 5, you can see the plateau region, but you can also see the drop in the sharp drop around 0 on the right and minus 5 decibels on the left. This corresponds to the cutoff frequency of the filter that we applied on a certain frequency. So here goes into the Q&A. The primary difference between the oscilloscope and the multimeter: the oscilloscope allows you to visually see the waves and stuff that you're recording. The multimeter just would rather give you values. The oscilloscope is also, you can change around the parameters to see the waves in different ways. You can use it to see alternating signals and not changing signals. There's also multiple channels that allow you to view multiple signals at the same time. Difference between AC and DC coupling. DC coupling shows both AC and DC. However, the AC coupling will only show a steady voltage, meaning any variations in the voltage will not be displayed. So anything that's alternating with the frequency is not going to be shown as shown in the previous lab. I believe it was on assignment 4. The purpose of the function generator is to generate the waves that we're trying to measure with the oscilloscope. Function generator is good for when you're trying to generate a certain electrical signal that is oscillating. You can set the frequency, and if you can set the frequency, you can determine the period. But also the output voltage is able to be changed over time. The 3 decibel down point of the multimeter, based on the measurements that we got, using the data from figure 1 on my lab, it was determined that the 3 decibel down point was around 600 kilohertz. This was determined by observing the point that the gain dropped down by about 3 decibels. This occurs at 600 hertz when the gain drop is minus 3.08 decibels, meaning that this is the down point. The down point is a little bit before that because of the decimal place, but that number is close enough where I was happy calling it that. The 2 sinusoidal signals that were shown, they were passed over if they were passed with the same filter from assignment 5 with the same 2 kilohertz cutoff frequency, the signal would not disappear completely or be removed. However, it would be greatly reduced because the filter cannot completely eliminate all the signal. It is minimized to like a point where it doesn't even really matter. The gain would be about the same from figure 2. This gain of minus 14.19 decibels allowed for the voltage peak of the signal to be calculated at 0.29 volts RMS. This is significantly reduced from the 2 volt RMS that was before it encountered the filter. That is the end of the slideshow. That's the end of the presentation I have for today.